Okay, this is lesson 7.6. Most of it you're going to find is a review, but we're going to talk a little bit instead of about quadratic equations, quadratic functions. And really, the only difference between a quadratic equation and a quadratic function is that we use the function notation f of x. So we've seen the standard form f of x equals ax squared plus bx plus c. And then in 7.5, when we learned about graphing, we learned the form called vertex form. This form is actually equivalent to, and I'll highlight it in green here, this form that we learned the other day. When we see f of x is we just use in substitution for y to denote that something's a function. So if I look at this vertex form and I replace f of x with y, this would read y equals a x minus h squared plus k. And you can see if I simply subtracted the k over to the other side, I would end up with this function or this vertex form of the equation that we saw in 7.5 when we were graphing. And we also talked a little bit about minimums and maximums. Remember, if a parabola opens downward, the vertex there becomes the highest point. So that vertex becomes the maximum. If the parabola opens down, then this vertex becomes the lowest point or the minimum. And it's actually the y coordinate of the vertex that tells you what the minimum or maximum is. And then a couple of more vocabulary words, which we've had many times before. The domain. The domain of a function is the set of possible x values as you follow the graph from left to right. So we'll talk a little bit more about that in a moment. And then the range of a function. The range is a set of possible y values as you follow your graph from lowest point to highest point. So let's take a look at this vertex form, which I said is essentially the same as what we were doing in 7.5. First thing I'm going to do is take this f of x and I'm going to replace it with y. So I have y equals x minus 1 squared plus 3. And then I'm going to subtract the 3 over to the other side with the y, so it looks just like the form we were looking at in class the other day. So x plus 1 squared. Okay, and then we picked out a couple of key elements from this vertex form. The first thing, the reason why it's called the vertex, is it tells us what the vertex is. Remember, we take the opposite of what's with the x for the x coordinate, so -1, and the opposite of the number with the y for the y coordinate. So my vertex is at -1, 3. And then looking at the number in front of the x, there's really a 1 here, which means it's positive. So that tells me that this parabola, when I graph it, is going to open upwards. So I'm going to go ahead and graph the point -1, 3, which is right there. And remember, this parabola opens upwards. So think about it and picture what the parabola would look like and decide if you have x-intercepts. You can go ahead and try to find the x-intercepts if you need to, but you'll probably get no solution and probably will waste some time doing that. So this parabola opens upwards, so there's no way it's going to have any x-intercepts. So let's now find the y-intercept. So if you remember correctly, for the y-intercept, we plug in 0 for x. So I'll have y minus 3 equals 0 plus 1 squared. So when you go ahead and solve that, you get y equals 4. So the y-intercept is the point when x was 0, y is 4. So I can go ahead now and plot that point. 0, 4, and I also forgot my axis of symmetry. So my axis of symmetry is this line that goes right through my vertex. Okay? So if you want, then you can find that point that's symmetric to the y-intercept, which would be actually right here, because remember, these parabolas are symmetric about that line of symmetry. And you have 3 points, so you can go ahead and graph your parabola. Looks something like this. Okay? All right. Now let's look at what happens when our parabola is not in vertex form. So I'm going to scroll down a little bit. This is when it's in general form, and we can actually convert this to vertex form using the process of completing the square. And we did learn that in 7.1. So just like I did before, I'm going to replace the g of x with y. So I have y equals x squared plus 4x plus 1. And then, just like we did every time we completed the square, we moved the constant to the other side. Now, before there was a 0 on the other side. Now there's a y, but that's fine. It's y minus 1, and I'm actually going to leave a blank because we're going to complete the square. X squared plus 4x. Okay, now if we recall the process of completing the square, we look at this number in front of the x, and we take half of it, which is 2, and square it, which is 4. So I add 4 to this side, remembering whatever you do to one side of the equation, you must do to the other side. So I add a 4 to the other side. So my equation now looks like y plus 3 on this side equals, and remember this factors, and it factors into x plus 2, x plus 2. Remember, the factors are going to be the same because we created a perfect square trinomial. And as simple as that, you can now see that you're in vertex form. So pulling out our key components of our parabola, we first need the vertex. So we take the opposite of the number with the x for the x coordinate, which is -2. We take the opposite of the number with the y for the y coordinate. So that's -3. And then just a note to yourself which way this parabola opens, because there's really a 1 in front of the x, and that's positive. This parabola opens upwards. So I'm going to go ahead and graph my vertex. It's -2, -3. Okay, and now this parabola opens upward, so it does have x-intercepts. So we can find those, but we can also find the y-intercept and use the symmetric point. So let's find the y-intercept. Remember, this is the equation we're using now. So to find the y-intercept, I'm going to put 0 in for x. So I have y plus 3 equals 0 plus 2 squared. Okay, so So that's y plus 3 equals 4. So y equals 1, which means when x was 0, y is, that's a comma, y is 1. So once again, let me put in this axis of symmetry here. It's the vertical line that goes right through the vertex. So 0, 1. And then if you want, you can just use the point that's symmetric to that. So the point symmetric to that, you just simply go 2 units over from your y-intercept. You go 2 units over to your axis of symmetry, and then 2 more units. And it would be right there. And there's your parabola. Okay, that wasn't bad, right? It's simply a review of completing the square. Okay, so let's move on to the next problem. The only difference here is that the process of completing the square is just going to simply get a little bit more complicated, because if you notice, we have a number in front of the x squared term, which we need to go ahead and divide that number out because we need a 1 there in order to complete the square. So again, I'm going to replace the h of x with y. So I have y equals, and I'm actually going to leave a blank. And I'm going to reorder these two terms. I'm going to put the negative 2x squared first, plus 4x. Okay, so if you remember correctly, we cannot complete the square with this negative 2 here. So I'm simply going to divide every term, including the y, by negative 2. And I know that looks complicated right now to have that negative 2 underneath the y, but it's just there temporarily. We're actually going to get rid of it in a few minutes. So I divide everything by negative 2, so I have y over negative 2. And again, I'm leaving a blank so I can complete my square, equals x squared minus 2x. Okay, and the one difference here is we did not have a constant out here to add to the other side, so it saved us that step. Okay, so now to complete the square, I look at this middle term, this negative 2, the number in front of the x. I take half of it, which is negative 1, square it, which is 1, and I add 1 here, and please remember to always add it to the other side. Whatever you do to one side, you do to the other side. So I have y over negative 2 plus 1 equals, and then I go ahead and factor this into x minus 1 squared. Okay, and we're still not quite done here, because remember that negative 2 we divided by? We don't want that y over negative 2. So to get rid of it, we're going to kind of undo what we just did. Remember how we divided by negative 2? Now we're going to simply multiply both sides of the equation by negative 2. So I'm going to multiply this side by negative 2, and that means everything on this side, and this side by negative 2. Okay, so what happens here when I distribute this negative 2, it cancels with that negative 2 in the denominator, so that's just y. And I distribute the negative 2 here, so that's a minus 2. Okay, and I can distribute on that side because there's no exponent up here. Okay, but on the right side, remember our PEMDAS rules, I cannot distribute that -2 into the parenthesis because of this exponent going on here. So we just leave it. We just leave it out in front. -2 x minus 1 squared. Okay, now if you notice, we are in vertex form. So we can go ahead and pick out our vertex. I'm going to come over here and right over here. Our vertex is the opposite of what's with the x for the x coordinate, 1, and the opposite of what's with the y coordinate of the y for the y coordinate. Okay, so let's go ahead and graph that vertex. So the vertex is the point 1, 2. And I'll draw in my axis of symmetry. Okay. And let's go ahead now and find our y-intercept. So for the y-intercept, we plug in 0 for x. So y minus 2 equals -2, 0 minus 1 squared. So y minus 2 equals -2. Adding the 2 to both sides, I get y equals 0. So I have 0, 0 for my y-intercept. So 0, 0. And that also happens to be one of our x-intercepts. Anytime the origin is your y-intercept, it's also your x-intercept. At least one of your x-intercepts. And then we can find that symmetric point to that, the one that's directly opposite it across the axis of symmetry. And then you have your parabola. So it opens downward like that. And in this case, we actually easily found, without doing a lot of work, if you were asked for your x-intercepts, we actually found them. Okay? And in this section, they don't ask you for all the details like they did in 7.5. But we actually found the x-intercepts. They were 0, 0, because remember that origin. And also, this point right here is where it crosses the x-axis. So, whoops, sorry about that. So your other x-intercept is the point 2, 0. So in this case, we actually found the x-intercepts without even really trying to find them. Okay, we're almost done here. We need to talk about finding the minimum and maximum values of a function. And we talked about that in the beginning. They actually happen when you are finding your vertex. The vertex is actually the minimum or maximum of the function. So we're going to go ahead and take this function here in number 4, and we're going to replace f of x with y. So x squared minus 3x plus 12. And we're actually going to put this into vertex form. Even though we're not going to graph it, we're going to put it into vertex form so that we can find that minimum or maximum value. So just like we did at the beginning of the lesson, we're going to move the constant over to the other side. So I'm going to have y minus 12. I'm going to subtract the 12 from both sides. I'm going to leave a little bit of a blank. X squared minus 3x. And now we're going to have to complete the square. And this is one of our ugly problems because the middle term is an odd number. But that's okay. We learned how to do this in 7.1. So off to the side, I'm going to say I have to take half of 3, which remember we just put a 2 underneath of it and called it negative 3 halves. And then we square that number, squaring the numerator, squaring the denominator, we get 9/4. So I'm going to add 9/4 to both sides of my equation. So we know that this side factors, and remembering what number goes in the parentheses, it's always the half of that middle number, so negative 3 halves. Okay, that saves us from having to do the x factor. And then over here, we simply have to add negative 12 plus 9/4, so we have to give them common denominators. So negative 12 plus 9/4. I'm going to turn the negative 12 into negative 48/4, multiplying top and bottom by 4. Negative 48/4 plus 9/4. Okay, negative 48 plus 9 is negative 39 over 4. Okay, it's a good thing they didn't ask us to graph this one because we really don't want to graph that point. So negative 39 over 4. Okay, so now let's talk about the minimum or maximum. First of all, which way does this parabola open? It opens up because there's a 1 here, which means it's positive, and it opens up. So we have the vertex. We can identify the vertex. The vertex is 3 halves, comma, 39/4. And because my parabola opens upward, it means I have a minimum value. And that minimum value is the y coordinate of the vertex. 39/4 is as low as this graph goes. 39/4. Okay, so they asked us to find the minimum or maximum and give the coordinates of the vertex. So there you go. The vertex is 3 halves, negative 39/4, and the minimum value is the y coordinate, which is 39/4. Okay, now we need to talk about domain and range, and which is really simple to do once you see the graph. So unfortunately, we're going to give a quick sketch of this just to show you, and some of you may be able to see it without doing a sketch of it, but most of us will need to just do a quick, and it just can be a rough sketch. So I'm going to rearrange this side, putting the negative x squared first, minus 2x, and at the same time, I'm going to go ahead and subtract the 8 over to the other side. Okay, remember, we don't want anything in front of that x squared. So I'm going to divide everything by negative 1, and it's temporary. Okay, just like we did when we divided it by the negative 2 in the couple of problems previously. So what I have is I have negative y plus 8. Okay, leaving a blank for my completing the square. X squared plus 2x. All right, completing the square, take half of the number in front of the x, which is a 1, square it, 1, remembering to add it to both sides. So we have negative y plus 9 equals, and then I go ahead and factor this side, so it's x plus 1 squared. And then remember that negative, we don't want that negative in front of the y. Okay, so from the negative 1 we divided by, now we're going to multiply back through by that negative 1. So negative 1 here and negative 1 on this side. Remembering we can distribute it on this side because there's no exponent on that parenthesis. So that becomes y minus 9 equals negative 1, and remember we cannot distribute it here because of that exponent right there. X plus 1 squared. Okay, so a couple of things they asked us to identify here. A was the vertex, so I'm going to start to list my answers here. Okay, we now know how to find the vertex. It's negative 1, 9. Now we need to talk about the domain. Okay, and here's where I'm going to give you just a really rough sketch of this parabola. It has a vertex of negative 1, 9. So negative 1, and let's just call this 9 up here. And then which way does this parabola open? Yeah, it opens down because of that negative 1 there. So like I said, this is just a really rough sketch just to demonstrate some information here. Okay, so now let's talk about the domain. The domain happens when you follow the graph from left to right. Okay, now remember we talked about this the other day in class. The parabola keeps getting wider and wider forever. So eventually it's going to cover everything from left to right. Okay, it's just going to keep getting wider and wider. So your domain is negative infinity to infinity. Okay, and that is actually the domain for every parabola that opens up or down. Okay, remember I said we're not going to be talking about, whoops, I erased my whole graph. We're not going to be talking about side-to-side parabolas yet. Okay, but we will be. We will probably talk about them when in future chapters. But for this chapter, we're only talking about up and down parabolas. So the domain will always be negative infinity to infinity. Okay, now let's talk about the range. The range happens when you follow the graph from lowest to highest. So if I start, remember this graph is going down forever. So if I start from low and work high, I'm starting at negative infinity. And how high does my graph go? My graph does not go past this y value of negative 9. So following it from low to high, it starts at negative infinity at its lowest point, and at its highest point, it goes to 9. Okay, that's not a negative 9. I erased my graph there. So the range is low to high. It's negative infinity to 9. And then the last part is the x-intercepts, or the zeros. Okay, that's the same thing. The x-intercepts and the zeros mean the same thing. It means what values of x make y 0. So to find our x-intercepts, we did this in 7.5. We go ahead and we take our equation in the nice vertex form, and we put 0 in for y. To find the y-intercepts, we put 0 in for x. To find the x-intercepts, we put 0 in for y. and we solve it for x. Okay, I'm going to scoot down here just a little bit. So what I have here is -9 equals -1 x plus 1 squared. Dividing both sides by -1, I get 9 equals x plus 1 squared. Okay, then square rooting both sides, square root, I get x plus 1 equals, and don't forget your plus or minus, plus or minus 3. Then one more step, we have to subtract the 1 over to the other side. And this was a mistake I saw a lot of people making in class. When we subtract the 1 over to the other side, we put it in front of the plus or minus. In front of the plus or minus, not behind it. In front of the plus or minus. So that's two values, remember? My two x values are -1 plus 3 and -1 minus 3. Everyone always seems to think it's plus or minus 2. The -1 needs to go in the front so you see your two values. So this gives me an x value of 2, and this gives me an x value of -4. Okay, so there's your two x-intercepts. That's part D, so I'll go ahead and write it over here for sake of room. Remember, there are 2 points. Your two x-intercepts are 2. X came out to be 2 when y was 0. And x came out to be also -4 when y was 0. Okay? And just to take a look at your graph, you can see from my rough sketch that an x-intercept of -4 and an x-intercept of 2 looks reasonable for my answers, for my x-intercepts. Okay, there you go. We will be working more on this in class.